all. Sorry about those minor technical difficulties. We're going to continue with the current network environment and gaming future vision panel. And I'll have to say I'm on Verizon, so please be kind to our guests. All right, and here we go.
Thanks, Renee. Good morning, good afternoon, and good evening. IGDA is truly a global organization. Welcome to the current network environment and gaming future panel. To thank IGDA for inviting us to participate. My name is Sandish Mooley, and I am the founder of Vistara Growth Partners. Vistara is an advisory firm focused on growth strategy and execution for small startups and large corporates. We have over 21 years of experience helping companies grow in various capacities. We are looking forward to an informative panel of experts from CableLabs, Comcast, and Blade Group. These experts have been monitoring current network conditions under shelter in place and also will share many of their perspectives on the future of video gaming and the coming network innovation that will enable great user experiences for end gamers, our mutual customers. At the end of our panel presentations, we will open it up to the audience for Q&A and welcome you to post your questions to the forum. Without further ado, I would like to introduce the panel and hand it over to Steve. Steve.
Hi, my name is Steve Glennon. I'm a technologist for CableLabs. We're a 200-person not-for-profit research, development, and innovation company. We're funded by worldwide cable operators through membership dues. We have about 62 member companies around the world in pretty much every geography. And our members serve about 200 million subscribers every day. So with that, I'll hand it on to Dean.
Yep. Hi, everybody. Dean Avgiris, Comcast Cable Strategy and Planning Group, focused on our consumer product portfolio. So across residential, video, broadband, mobile, home, etc. Happy to be here, part of the discussion, and looking forward to furthering our work in partnership with the gaming community.
Hi, my name is Asher Kagan. I'm the co-founder of Blade. At Blade, we created Shadow, a PC cloud gaming solution to be able to provide to the gamers an access to their favorite games on every possible display, every possible platform, so they will be able to play any game, anytime, on any device they want at the best experience.
Thank you, Asher. Steve Glennon will start by sharing his current perspectives of the network in our new normal, as they say.
So thank you, everybody. CableLabs, you know, we sit at the center of the cable industry. We are we represent all these member companies. Half of them are mobile network operators. So we get some interesting kind of insights into what's happening within the cable industry. The big claim to fame we have is we kind of own the cable modem specification on behalf of the worldwide cable industry. So that's where we get to impact some of the outcomes. So I want to start, if I may, with a little bit of levity. Before the COVID-19 activities, we were really getting to the point where video gaming was being considered as an addiction, at least as a mental health disorder. But interesting how the news changes that now video gaming is turning into something that's therapeutic for dealing with some of the stresses of being cooped up inside for an extended period of time. So I want to share some data. This is all public data. But here we have some interesting statistics made public by Comcast that show some of the network impacts. Obviously, the big things we're seeing here is an increase in upstream traffic, and a lot of that is driven by video conferencing. So Zoom have made public that they've gone from 10 million users in December to over 200 million users in April. So we're seeing massive growth in upstream use, largely focused around the growth of video conferencing apps for general interaction. An interesting dynamic on mobility as well, that LTE usage has gone down because people aren't out and about with their phones as much, but the mobile Wi-Fi utilization has grown significantly. And this is a kind of testament to the fact that even with mobile, use of home Wi-Fi is a huge amount of network traffic and how people are consuming on their phones. The last statistic down here we have of 700,000 network diagnostic tests. There's a pretty clear indication that people are concerned about their network performance. They're seeing issues and they're running a test to find out what's happening. So we're certainly seeing people doing a degree of self-diagnosis as to what's happening with their networks. So I think one of the key questions we have is, well, how well is it holding up? We have a couple of quotes here from Comcast and Charter Communications. You may know as Spectrum. They really talk to that the networks are holding up very well. I want to give you a little bit of insight as to how that works. A lot of the cable networks are really long timeline investments. There have been, I think, hundreds of billions of dollars of investment of private capital to create the cable infrastructure. And a lot of that is the wires you see at the side of the street attached to poles, but there's also a lot of infrastructure in the ground. And we end up with fiber optic nodes that convert from fiber distribution to coax going to homes. And a lot of the capacity growth comes around doing things called node splits, where you're taking a node that would have served a certain set of houses and actually turning it into a node that serves half as many houses, basically doubling the available capacity for the houses it serves. So these node splits are a fairly long-term investment involving putting new equipment into the field. Going beyond that and actually pulling in more broadband infrastructure, more fiber, putting more coax in is actually a very long-term activity. So it's something that has to be planned very far out ahead. And our member companies give us a little degree of insight into the kind of capacities that they run their networks at. And they typically run their networks with a very significant percentage of available peak capacity to deal with instantaneous peaks and general growth, and typically have a kind of a 1 year plus timeline for detecting growth and adding more network capacity. So this is something, it's not like, hey, we're doing this massive reaction. The network is built to handle significant growth and has been able to deal reasonably well with the massive growth in traffic from COVID. And you'll see some things in terms of maybe some increases in latency, but in general, the network has held up extremely well and has been able to deliver service to most everybody who's on a cable network. Moving to more game-specific information, what we see here is a massive uptick in game utilization. So here from Verizon, say a 75% increase in gaming. And on the right here from Comcast, the game downloads are up a very significant amount, up 80% during new releases. Now, the reality is, in terms of the day-to-day use of gaming, the issue is not around capacity for downloads. The real issue is around the real-time gaming aspects and data traveling back and forth in real time. And it's actually very low data rate. A typical game will have about 150 kilobits per second of real-time game traffic going back and forth on the network. So playing the game is actually not really such a huge deal. It's everybody else is the problem. It's my favorite thing is that gamers are not the problem. It's everybody else who's the problem. And when we see an increase in game downloads, that impacts it, but also increases in streaming video. So here's something from Akamai where a lot of the companies you see, like Microsoft and Sony, who have major downloads through their Xbox and PlayStation platforms, are actually behaving responsibly here and saying, look, rather than just throw everything at the network when we have new releases, they need to behave responsibly, and they're working with their CDN distributors, Akamai here, to really try to throttle the download speed, so they're not throwing massive full-speed downloads with hundreds of thousands to millions of users downloading the game updates at the same time. So this is kind of the people who are the primary users of massive capacity on the internet are behaving responsibly in a time which is really a massively atypical crisis, so that it's really for the common good, and they're kind of managing the download speeds to help not cause kind of a massive problem for regular users of the internet, which is really becoming kind of critical to people's daily lives. There's also something I want to highlight here, which is around the social responsibility. Clearly broadband is becoming a necessity for many people. And here we see Charter and Comcast are doing work to try and help deal with people lower incomes who need internet connectivity to be able to do work from home, teach from home, kids at home, to really be able to do the right thing and help people continue to have this essential function of being able to get to the internet to communicate with others, to have a sense of community, but to learn and consume and be entertained. So with that, let me hand this over to Asher to move on and give some of Blade's input.
Yes, thank you very much, Steve. So on the perspective of Blade, let me share the screens. First, the big C that we saw immediately is that the demand for cloud gaming, and we found out that people tending during this pandemic not only to hoard the toilet papers, but also to hoard the cloud gaming PC. And that's the first impact that we saw. We saw a big explosion on the numbers of sales and the demand that we needed to put a new infrastructure, which actually during those time caused us to install some infrastructure in data centers through video calls and instruction like this. And that's we saw the waiting list going up to 5 weeks for around those days to just be able to get the service. And now, in terms of the traffics and the sessions, we saw that probably as expected, the gaming industry is taking much more of the available time of the people right now. And we saw a raise of up to 80% and even 100%, doubling the numbers of sessions that we have per day. And another very interesting learning that we saw is that actually even before the stay at shelter orders and the confinement at home, we already saw starting to have a big raise, which show us actually that the gamers themselves was actually even before it became by the state law, by the country law to be confinement, they already spend a lot of their spare time, much more of their spare time on gaming. And also another very interesting shift that we saw is that pre the COVID-19 era, most of the peak time was around the evening hours, around the 8 p.m., 9 p.m., and of course the weekend. And during the COVID-19 era, we saw much more shift towards the 5 p.m. and the earlier hours of gaming activity. Now, the last interesting thing that we saw is that we also saw a Shadow providing basically a full PC to the users, that they can use it not only for gaming, but also for software, for internet, for office usage, and of course for designer tools and developers tools. We saw a big increase on the sessions that are not gaming sessions on Shadow. That's people using the advantage that they have an access to a high-end graphic card and high-end computer, PC computer, to utilize it, to use it for their home and to use it for the work. And unlike the laptop or the computer that they have, that's basically stuck with them at their home and confinement to their home, exactly like their confinement, with cloud PC, they don't have this limitation, and they can share the computer with their colleagues, with their peers. And we definitely saw this trend going up strongly during the COVID-19, and especially for game developers that need access to high-end graphic card. Now, the other impact that we saw is definitely on the network. And on the network aspect, we already saw a big difference between the cable infrastructure and the ADSL and VDSL infrastructure, where we launched the service, the Shadow service, initially in Europe, where most of the users are connecting through ADSL and VDSL. So, and when we launched it in the United States on early 2018, the first thing that we noticed is that first, comparing to the ADSL and VDSL, the cable have much more better latency and also more stable latency, where in ADSL and VDSL, it's very much depend on the distance from between your home and the node. Now, on the cable infrastructure, what we also saw is that during the day, the Shadow service on the early beta that we launched was working perfectly. But then on the evening and on the weekend, when we started to have a lot of congestion on the last mile, that's where we started to see issue with the experience. So we did a strategic partnership with a cable company like Charter Telecommunication that help us a lot to understand how the cable network is working. And allowed us to build an algorithm that we can forecast the status of the internet in the next minutes or in the next hours, and adjust automatically the bandwidths and all the ways that we are sending the traffic according to that, and to provide always smooth experience also in the weekend and the evening. Now, that's also prepared us a lot to deal with all the surge that we had during the COVID-19 of people using the internet much more massively, and to provide solutions that the service still continue to function and still continue to work and adjust itself to the new congestion that's in the network. The interesting thing that we saw about that, it's exactly like you mentioned, Steve, that with Charter communication, with Comcast, we saw that the ISP network didn't have any issue to handle the surge in traffic, while with some of the European ISP, we actually got contact from them to reduce a bit the bandwidth and to help them a bit to reduce the load from their network. However, where we actually saw a big issue with the network was on the Wi-Fi network at the home, where now all the family is confinement to the home and everyone is using it, the parents using it for work and for video conference, the kids are using it for school and for playing games. And it was increasing a lot the traffic and the congestion on the Wi-Fi network. And this is exactly where we're starting to work now with CableLabs to work and implement protocols to make this latency and stability of this network much, much better. And I will let you, Dean, to continue to explain it from the Comcast perspective.
Yeah, thanks, Asher. Helpful intro. What I'm going to do with that context is, shift the discussion a little bit towards, non-COVID related themes, and also sort of the future vision for, our network and how we participate in gaming. But just to quickly start off, 2 minutes in terms of overview on the company. I think most of us have probably heard of Comcast or one of our brands or affiliates, but we may not know the breadth of the enterprise or some of the brands that fall underneath that umbrella. And, as we increasingly look to work with and engage with the gaming community, this is the portfolio that we bring to the table. So, Steve, on the next slide, Comcast Cable represents our, American cable assets. And this is the piece of the enterprise that I focus on, specifically our consumer product portfolio operating under the Xfinity brand. Our two largest lines of business, as you can imagine, are our video, which comprises our traditional cable TV distribution business, and is highlighted by our X1 platform that integrates linear video with DVR, VOD, and third-party apps like Netflix, Hulu, and Prime. And then obviously our broadband business, which we're talking about today, primarily the largest in the nation and sits on top of the X5 platform, which combines speed, coverage, control, and security for an integrated experience. On the next slide, extremely quickly, in terms of highlighting NBCU, the main broadcast network houses everything from news and sports to late night and SNL. We have one of the largest cable network portfolios across general lifestyle brands, sports, news, and niche programming. Our film division has hit franchises we've probably all seen, like Jurassic, Fast and the Furious, and Despicable Me. And then finally, our parks business has some of the most sought after attractions in the world. On the next slide, last year we acquired Sky to expand internationally and now have assets in Europe, primarily in the UK, Italy, and Germany. Those range from a direct-to-consumer business with Sky Q and Now TV to also including Europe's leading sports, news, and entertainment content. So with that background, on the next slide, it's sort of that context that I use as a backdrop and come to our desire, I think, to more meaningfully participate in the gaming space and to work collaboratively with gaming platforms and the developer community and what that vision sort of looks like. The way I think about it, the game developer community creates this amazing content, these truly, immersive and engaging games and experiences. And Comcast Cable really provides the platforms the connectivity and the content distribution to really enable a premium gaming experience, especially as things like multiplayer, social, team-based gaming, Twitch, YouTube, etc., continue to become more mainstream. So really, we have the same customers and, the same desire to super serve those customers and continuously improve the user experience. So I'll touch on that across these sort of 3 pillars that you see in blue here. What have we done so far in the space? Obviously, you'll see here our branding and participation in the esports arena, pun intended, I guess. You'll recognize our investment in the Philadelphia Fusion, which compete in the Overwatch League and made it to the grand finals in 2018. I think they're currently in first place. Esports is one of the few leagues that is still operating, so go Fusion. And also late last year, we also announced a JV with SK Telecom in South Korea to launch T1 and really broaden our international reach in competitive online gaming. Finally, just last month, we announced our partnership with the Overwatch League to be the lead presenting sponsor for the 2020 season. So clearly, there's a lot of interest to work with developers and content producers in this area. I think it's safe to say that the future vision of our involvement in gaming is going to include esports and competitive gaming. And we're really excited to see how that space grows and continues to develop. So with that in mind, Steve, if you go to the next slide, we have a short sizzle reel here. I hope that this comes through on the broadcast. So fingers crossed. And Steve, when you're ready, go ahead and play. Great, thanks. So again, a space we're pretty excited about. Now as we transition from sort of our promotional efforts to our core assets, first and foremost, our primary asset and our main source of competitive differentiation is our network. Steve touched on it, Asher touched on it, from the thousands of miles of fiber that we run across the country, all the way to the Wi-Fi that we use to blanket our customers' homes. The network is really engineered to be fast, resilient, and impactful. But, moving beyond speed and capacity, we recently announced in the IETF Internet Standards Organization our support for a technology called Low Latency DOCSIS that Steve is going to touch on momentarily. It's our hope that this technology, which Steve will do a better job explaining than I, will be yet another enhancement to the already robust network and really drive meaningful and tangible upgrades to applications like gaming, video conferencing, work from home, etc. On the next slide, I want to take a minute and talk about the consumer experience in the home. We know that a strong broadband connection is critical to the gaming experience, but I think the change in philosophy that I've seen recently amongst ISPs is really about honing in on what is a strong broadband connection and what that means for this segment, specifically gaming, and moving on beyond speed as the sole differentiator. So in that vein, there was probably a misconception historically that gamers exclusively hardwired their PC or console to their modem. But our research shows that Wi-Fi is overwhelmingly the preferred medium for connection in the home. As Asher was discussing, as folks engage in competing use cases, and especially when you have kids or roommates Netflixing in a different part of your house, Wi-Fi congestion can become a real inhibitor to gaming. So along with our new XB7 gateways, we are constantly looking at new technologies and protocols to prioritize gaming on Wi-Fi and really make the experience seamless. I won't spend too much time on usage because I think we all know the trajectory that that's going, especially in a COVID work from home, learn from home world. But on the far right there on latency, I think that is now in bright headlights in terms of how important it is to this segment. And so in addition to the low latency DOCSIS network work that Steve is going to discuss, we are always looking at ways to reduce in-home latency and really give our customers, our gamer customers, a competitive advantage. And that's something that I think is a prime opportunity for us, the ISP community, to work with the gaming community on. On the next slide, yet another sizzle reel, fingers crossed again. But this kind of speaks to these enhancements that we've been pursuing and the evolutions in thinking. And what I really love about this video is how authentic it is, and I'll explain why in a second. Steve, go ahead and run that for me, please.
Xfinity, my internet company, is sponsoring us.
In literally 5 to 10 minutes, I can download 60 gig games, which has been literally the most amazing thing ever.
Gary's over there. He uploads YouTube videos at the same time while I stream and while I play Fortnite. So it's GG's all the way around.
Fast and reliable, just like Xfinity, guys, okay? I don't make the rules. Compared to the other internet companies I've had, it's just it's by far number one and superior.
It's a great internet. It's the GOAT ISP, man. You can rely on it. You can count on it. They help me get everything I need to get done.
Maybe your current Wi-Fi is a little finicky. Let me help you out there. Xfinity X5. Strong, reliable, fast connection.
Thanks, Steve. And I guess, aside from being competitive gamers and popular streamers, these guys are also Xfinity customers. And it's really meaningful to us to get them using our products and talking about how they improve their gaming experience, which I think, again, points to our vision for our platforms going forward. On the last slide here, I'll wrap up by saying, again, we know how reliant gamers are on our assets, and we are working towards a vision that serves them with products and experiences and services that are tailored to sort of meet their needs. And to do that, though, I think it's critical to work collaboratively with the gaming industry because we each own pieces of the puzzle, whether that's working together on promotional efforts or knowledge sharing to solve usage issues, or partnering together on low latency DOCSIS or Wi-Fi. At the end of the day, it's in both of our best interests to keep innovating and to keep improving the end user experience, which I think is something we can do together. So with that, I'll pass the ball back to Sandesh and to Steve, I think.
Thanks, Dean. Next, we'll have Asher talk a little bit more about the vision that Blade is seeing for gaming. And Asher, if you could share your slides.
Yeah, thank you very much, Sandesh. Let me see. Okay, hopefully you are seeing my screen. Now,
yeah, we're not seeing it. I think if you're on two screens, it's sharing your. It's not sharing your PowerPoint.
Okay.
If you like, I can pull it up and share it.
Wait a second. I will try it like this. Okay, is it good now?
Yes. Perfect.
Okay. So just to speak first a bit about what the role in cloud gaming in the gaming industry, and the way that at least I, as a gamer, I started to play in a very, very early age. I think actually my first picture, it's with 2 years old with a pacifier on my Commodore 64. And the gaming industry and the games, the content was always the engine that's pushing the technology industry forward. It was always demanding more faster CPU, more stronger GPUs, and it was always leading the technological advance. However, the how we are playing, the way that we are consuming the content did not change at all during the last 4 decades. It's exactly the same kind of friction that's standing between the gamers and these games, his content are still existing today. Still today, to be able to play a game, you need to spend $500 on a console or $1,500 on a PC. You need to upgrade it every 3 years, every 4 years to replace it or to upgrade the GPU. Every time you have several types of devices. So either you are going on a console and then you have the living room gaming experience, or you're going on a PC and then you have much more vast majority of genres, but you are limited to play on your desktop or a laptop computer. And of course, it's not a mobile. You're always stick to play on the same machine and you cannot take it anywhere with you. And this kind of friction between the gamers and the content, it's exactly what the cloud gaming industry want to solve. And there is, just as we will be on the same page with everyone, there is several approaches on how to do cloud gaming. You have companies that selected to do cloud P2P gaming, which is basically means that you are installing a small software on your gaming rig at your home, and then you can access your gaming rig either from your TV, either from your mobile device, either from another weak laptop or things like that, and playing directly from the gaming rig that's in your home. It, of course, doesn't solve the upfront cost issues and the upgrade cycle issue and the hardware compatibility of the games, but it's bringing you the portability to be able to play anywhere. There is also the second approach of catalog cloud gaming, which is basically displaying a catalog of games, kind of like Netflix experience for gaming, where you have a catalog of games that's a catalog of 40, 100, or 500 games. That's you selecting the games and launch it directly. Now, the problems that we are seeing at Bladed with this industry is that for the game developers, they need to be the one in touch and in contact with the gamers and with their market. And by doing a catalog of games, it's also putting another link on the distribution channel, and it's providing, it might have a risk of dictating the game developers of how the revenue model should look like, how the game should be distributed to the gamers. And we really want to let the game developers, with Shadow, we really want to let the game developers to own this experience with the gamers. And that's why on Shadow, we went on an approach of a cloud PC gaming. So basically, we are providing to the user a full high-end PC that is remotely, a remote PC. They are getting a full Windows 10 operation system. They can basically use it exactly like they use their local PC so far, only that, of course, they can access it from any device, and they have freedom to play any kind of game that was released for the PC, just like they playing it. They were used to play it on a local PC. They installing whatever online store network programs that they like to use. They can bring all the games that they're already on. They can buy the new games through that, and exactly to use it the similar way that they are using a gaming PC. But of course, they don't have any upfront cost like a PC, and that's we are seeing removing a big barrier from this content market. That suddenly you don't have the $500 or $1,500 ticket just to be able to enter the market to consume game. And of course, it's providing you the option to play on any device, whether it's your old laptop or your TV in the living room or your mobile device. And it's always staying up to date. And this is really leading to the vision that we have for the gaming industry, is that first we are thinking that exactly like the video streaming industry, which was increasing industry of the DVD rental and all the physical media rentals that had a lot of friction. It was limited to be a $5 billion industry, and now with Netflix and all the streaming solution, it's grown up to be a $150 billion industry. The same thing by removing the huge barriers, the huge limitation of high entry ticket, be limited to play only on this specific device that you bought and not be able to play anywhere. It's really creating a mass extension of this market, and we are already seeing that on our existing user base, where actually around 60% of our user base doesn't own even a gaming rig or a gaming PC, and now they suddenly have access to gaming content. Now, this is exactly where we want to work with the gaming industry and the game developers, is that first to develop all the kind of multi-platform support for their games, so they don't need to release a lot of version for each type of platform, but they can release only one version that's working on every platform. That's the client and their target addressable market suddenly growing a lot, because the gamers doesn't need to check the minimal system requirement. They can know that it's just work. And the same way we want to add, not only by removing friction from this industry of today, but also to evolving the industry, because cloud gaming bringing a new opportunities of new aspect of social gaming, that suddenly we can develop games that have a new type of interactivity between the users. Since we have a real-time technologies to stream the computers to everywhere, we can create an experience that's you are playing a characters, you can move the full control of this character to your friend and to create lots of new social interaction between gamers. And of course, the fact that suddenly, as a game developer, you are not limited anymore to the single GPU or the single CPU that's in the client local machine, but we have rooms that's full of GPUs. It's actually the first time in history that we have rooms that's containing 20,000, 30,000 GPU in the same room, that we can leverage all this compute power to create new type of experience and new types of AI for single player or massive multiplayer games. And this is exactly the type of impact that we would like to provide to the gaming industry with cloud gaming. Now, of course, also on the network side, we always wanted to bring the experience that cloud gaming and shadow PC will work exactly like a local PC. So first, we developed a lot of input protocols that's allowing you to connect any kind of USB peripherals that you have, or any kind of even a USB storage, and you can connect it to your local client, and it will work in Shadow out of the box. The same way that every game working directly out of the box on Shadow. Now, there is always the aspect of the quality and latency of the service, and this is where we are looking ahead for doing partnerships like the ones that we did with Charter Communication, to be able to improve and to be able to work with companies like CableLabs, like Comcast, like Charter, to really bring the data center to the home of the user. So really to be able to develop and adapt, for example, our streaming protocol to the low latency DOCSIS protocol that Steve will speak about, and also to be able to migrate our infrastructure footprint closer and closer to the edge, to allow really super competitive gameplay where the latency is important in the level of the millisecond. And I will bring it back to you, Sandesh, to explain about those technologies.
Thanks, Asher. Steve, would you like to talk about the future vision and some of those technologies? Thank you.
Yeah. So we did some gamer research to find out, what were the problems gamers face. The typical scenario that was described among 1,000 kind of core gamers was happily playing your game with great latency and responsiveness, and then someone in the house fires up a streaming video session. I mean, here we show Netflix, but it's any video streaming session, and suddenly the latency becomes massively variable. They see a bunch of jitter, they're missing shots, and they are lagging out of games. So that was kind of the pain point we had expressed to us. So we then kind of go on and take a look at, well, okay, how bad is it? So we're able to get some real data. Here's some example data from North American ISP that kind of shows the latency curve for traffic. And you see the median latency, which is, we can use the term average loosely, is about 18 milliseconds, which is not too bad. The 99th percentile latency, what that really means is like 1 packet in 100 is getting 200 milliseconds or longer, which is a real problem. And you start to kind of see this out to 99.9 percentile, so 1 packet in 1,000 is getting latency of about 1 second. 1 packet in 1,000 might not seem like a lot, but when a game is sending 30 or 60 packets per second, that's about once every 30 seconds. Yep.
Steve, for some reason the screen share is not working.
I'm going to try and fix that. So, share. There we go. There we go. So, thank you. So, you see it now? Okay. So what you see here is, the 99.9 percentile, meaning 1 packet in 1,000, is seeing 1 second or latency, and 1 packet in 1,000 is every 30 seconds. That's really kind of not a great situation. So the question is, why is it so varied? And it takes us a little bit to the model of how cable broadband communication works. On the left, we have the cable modem that sits in your house, called the cable modem termination system that sits in the cable operator. And the communication over the coax uses a downstream communication channel and an upstream communication channel. Here we, showing, for example, 100 meg down, 20 meg up. And there's basically one queue for downstream traffic and one queue for upstream traffic. So if somebody in your household is running a speed test, then all of their speed test traffic is going into this queue, and that queue is designed to hold a lot of data to get the best possible throughput, and it can end up being 200 milliseconds or more of data sitting in that queue. So when your gaming state packet gets queued up to be transmitted, it's sitting behind 200 milliseconds of somebody else. At the beginning of this, we said, video gamers are not the problem, it's everybody else, and this kind of talks about that. In the downstream, if you've got streaming video coming down, somebody in the house is watching Amazon Prime or Hulu or Netflix, then the video that's queued up to come down to them varies in this downstream queue and builds, varied depth of the queue up to a couple of hundred milliseconds, sometimes more. So your downstream gaming traffic is sitting behind this varied amount of queue traffic. You may have heard of the term buffer bloat. That's kind of what this is about, where you end up with a bunch of buffered data that is stopping your timely traffic getting through in a timely fashion. So how we've gone about fixing this is to redefine this as a software upgrade to the existing gigabit cable technology, to split the downstream into two separate service flows. They share the same kind of aggregate capacity, same in the upstream. We split it, it shares the same aggregate capacity that it previously had. But there's now a classic queue that takes all the existing traffic. If you hear about TCP, most of these streaming protocols, most of the internet is delivered with TCP, and generates these deeply buffered queues. So that lives in the classic model. But when you have a gaming packet, the idea here is that the gaming packet goes through a classifier that identifies, hey, this is a gaming packet, we want it to get low latency treatment, and it ends up in this low latency queue. That queue is much shorter. It's typically well protected so that there's not a bunch of traffic in it, so that the game traffic will now get an early shot at going out over the network, rather than sitting behind the streaming video waiting to go out. Similarly, in the upstream, you do your button clicks, the classifier says, hey, that's a gaming packet, and it sends it into the low latency queue, and the low latency queue goes upstream without sitting behind all the speed test traffic in this example. You see this QP thing, this is called queue protection. One of the questions we often get is around, well, what happens when everybody marks their traffic to identify it as game traffic? The queue protection function, its job is to monitor the depth of that low latency queue. And when that low latency queue starts to get above about 0.5 millisecond, it starts to identify which flows of traffic are causing that queue to build, and then redirects those traffic flows into the classic queue to make sure this low latency queue is pristine for well-conforming traffic that generates the right behaviors to not build a queue in either the downstream or the upstream. So to give you an idea of what this really means, here we've got some figures for some latency and jitter characteristics. This is a very aggressive jitter characteristic. It's the 99.9 percentile. so maybe bigger than you're used to seeing. What we see is DOCSIS 3.1 is the gigabit cable technology. There's a technology for latency reduction called active queue management. If that's turned off, we might see latencies of round trip of about 27 milliseconds, but very high amounts of variation of jitter. When you turn active queue management on, we more than halve the average latency, and we about halve the variation in the jitter. The thing we've defined is this thing called low latency DOCSIS, and what we're expecting to launch here is this green column where we say, this is the baseline model without a feature called proactive grant service. And here we can start to get round trip latencies that are pretty reliably in the 3 to 5 millisecond range, average latencies of 3.4 with a variation of only 2.8 milliseconds. We have a feature that allows us to get to sub-millisecond average latency with tiny fraction of a millisecond of jitter. So this is what's coming. I want to give you some quick examples of what this really looks like. Here is 2 minutes of gameplay. And what we show here in the blue is what's happening to game packets when we're running Twitch, someone in the house is running a speed test, someone's running Amazon Prime Video. You see some pretty significant variation in the latency when the speed test kicks in. With the orange traffic here, you see the impact of this new technology on the cable link, that in that same scenario with that same traffic, we end up with a very reliable low latency. Wi-Fi, we've talked about the fact Wi-Fi is used extensively. Here's the same impact of identifying traffic on Wi-Fi. Not quite as marked as on the cable leg of this, but we get some major improvements in Wi-Fi latency. So again, the blue here is traditional traffic, and then the orange is the identified low latency traffic. So here we come to, well, what's the ask? The key thing here is that we need your help in identifying the game traffic. It's not easy for us as ISPs to robustly identify traffic. So the ideal solution is that the games themselves identify their latency sensitive things for real-time flows. And then this classifier can trigger off of this feature called differentiated services to send the identified low latency traffic into the low latency queue. For Asher's situation with high bandwidth gaming, it's a little more complex. This technology called L4S, low latency, low loss scalable throughput, a proposal in IETF, allows us to get very high throughput with very low latency, but it requires a little bit more intrusive changes into the game streaming platform. Not the games themselves, just the game streaming platform. So this impacts the like of Azure and technologies such as xCloud and Google Stadia. And we're working with several of those companies to try and make sure this is taking place. So with that, I just want to close and say we've created a landing page called pinkspikeskill.com to try and register interest to sign up for more details on this. You can email lowlatency@CableLabs.com, and we will respond to your questions and key you into some of the example code we have of how to add this to your game. It's trivially simple. It's typically 1 to 2 API calls during socket initialization. So we really want to help facilitate the gaming industry to leverage this technology. With that, I'll hand it back to Sandesh.
Well, thank you, Steve, and thanks to all our panelists and IGDA for having us. We've got a lot of great questions that come in, and I know we've got limited time here, so we'll try to get through as many as we can. In terms of the first question, how do you view the network holistically, sort of round trip, end to end? Which areas are most vulnerable or have the most to gain from improvements in the network for gaming applications? And I think maybe Steve and Asher can potentially speak to that.
So, I mean, just in a quick summary, there are many legs to the route that a packet takes. There's Wi-Fi in the home, there's the cable network, there's the core network of the ISP, then there's the internet, and then there's the server data center. In terms of the COVID thing, we're seeing an increasing capacity, but typical traditional gaming traffic, not game streaming like Asher's, is really very low throughput. It's 150 kilobits per second. So in general, it's got a pretty easy trip. And the only problem it faces is the other traffic. If there's massive upstream from video conferencing applications or massive game downloads, or a lot of people are watching live videos, that's the kind of thing where TCP traffic causes buffers to kick in. So really, it's the massive growth of other traffic that's an impact more so than the increase in gaming traffic. Over to you, Asher.
Yes, exactly like you said, Steve. The bandwidth itself is less than an issue with what we're seeing in the gaming traffic, which is usually kept in quite low number. However, the latency is definitely a very important factor when you are trying to develop a multiplayer game and to synchronize between all the actions of the gamers. And this is a lot what we're seeing is that the importance of placing your server strategically in geographic strategic allocation close to the end users and to plan it correctly. I think this is something that a gamer developer definitely need to put the focus on. With the cloud gaming industry, it's a bit different because the communication between the game and the game server is done from our data center to the game server data centers, which usually we have a very quality peering between them and optic fiber infrastructure. But when you are playing from a local PC and from those kind of solution, it's definitely important to strategically place the servers in the right position to have the right latency for the game.
Great, thank you. Next question. Would massive adoption of streaming games have an impact on the network stability, causing big surges? And also, what would this mean strategically more broadly in terms of opportunities? So I'll open that up to the whole panel. Steve, you want to take a crack at that?
Yeah, I'll take a crack at that. I mean, typical game streaming is, it's not a whole lot different than video streaming for, Amazon Prime or Netflix. You might see data rates in the 6 to 10 or 12 megabits per second. We've heard some numbers, with Stadia going up to 40 or 50 megabits per second. That's a significant growth in the network, but it's growth that we welcome. People becoming more dependent upon the cable network and the quality of the cable network to deliver compelling experiences. As we see that growth coming as an industry, we increase the capacity of the network. If it were to turn on overnight, that might be challenging. But I think the reality is we'll see this growing and we'll be able to react appropriately to those growths in capacity demand.
Great. In regards to different types of traffic on the network, games, media, social tools, how do you look at some of the technology to improve the network stability across those different types of?
So one of the things we have here is, we talk about this, one of the questions coming up on Twitch has been around how do we use APIs to communicate with the cable modem. The way you do that is not through APIs to the cable modem, it's through using packet marking in the IP packet headers. So that's the key technology to identify traffic. That's happening today. So our favorite application, of Zoom going from 10 million users to 200 million users, Zoom uses this traffic packet marking to identify their traffic, and they already get some of those gains in latency and jitter on Wi-Fi. So I think this technology allows people to identify appropriate traffic that will bypass this kind of growth issue of utilization, because we kind of cut through the noise of other traffic when you enable these technologies.
Yeah, and I definitely, on the point of comparing basically the Amazon Prime stream and the Netflix stream to gaming streaming, it's definitely the same type of traffic, but with one difference is that on game stream, and same actually for Zoom and video conference, you don't have the luxury to have a buffer, to be able to buffer some of the frames. You need to transfer every frames in real time. And this is especially where we're seeing the importance of marketing the traffic and doing all the peering correctly. For example, our peering strategy is to peer directly with the operator, directly with the ISP, so we can avoid to go the traffic, to stream the traffic through the IX and through the backbone of the internet, and be able to reach on the minimal number of hops to the end users. And of course, the more close to the edge that we can locate our data center, the better it is from this perspective.
Mm-hmm. Got it. And I guess in terms of how often should a gamer consider upgrading their Wi-Fi router or receiver? And second, sort of follow up to that is, how do you tell if the bandwidth is sufficient, and considering potential caps in some of the network analysis that you do?
So, very good question. I will let Steve to answer this one.
I can also jump in, Steve, when you're done. Go ahead.
Yeah. The reality is this technology of it's called Wi-Fi multimedia, that's using this packet marking to help identify traffic and give it lower latency. It's been around since 802.11n. There have been some significant improvements across Wi-Fi access points over the years. There's not like a standards thing that says, oh, I have to have Wi-Fi 6 to enable this technology. It's around today. Pretty much every access point that's out there supports this technology, and it's simply a matter of activating it. Having said that, Wi-Fi 6 does have some additional tools that help to improve latency. There's a technology called OFDMA that helps with that. But that adds to that's additive, right? That helps further. But this is a core technology that makes a huge difference on existing access points and carries forward into Wi-Fi 6. Over to you, Dean.
Yeah, no, Sandesh, towards the end of the question there, the asker was curious as to how they can sort of measure latency performance and network performance. For sure, that's something that we're tracking. We recently deployed speed tests directly to our gateway and also to the end user devices in the home. So through our xFi application and elsewhere, our customers can get an immediate snapshot of how their network is performing at that time. And so that's A, helpful. And then B, also to Steve's point, some of the issues that we do run into from an in-home connectivity perspective are when folks have older model third-party access points, and part of these tools are to enable customers to have that sort of visibility and maybe drive the upgrade decision on their behalf. Great.
We probably have time for one, maybe two questions more, just given we're running a little over here. In terms of the LLD, LLW, is there an API doc or an application to access the modem AP to use the low latency queue, and how would we go about doing that?
Okay, so we've actually put up a website. We actually have a GitHub repo with some example code. We've already provided this to some game technology companies that show how to identify your traffic. You don't really talk to the AP or the cable modem, you identify your traffic. And we show example APIs of how to do that in Windows, how to do it in Mac, Linux, BSD. We're expecting to grow that into some of the console platforms to give example code for how do I do this. And for traditional gaming, it's typically one or two API calls, and we're giving direct examples of that, which is linked. If you go to the GitHub repo, which is linked from the pingspikeskill.com, you'll be able to see some example code for that.
Great. Well, thank you everybody for your contributions today. Really enjoyed the discussion. We do have a number of other questions that have come in, and I'm so sorry we won't be able to get to them, but feel free to contact any one of the panelists with your questions, or visit pingspikeskill.com for more information.